Okay, David, David, you can hear me now, right? Gosh, I'll have to cut that. I was like trying to find something this whole time and I muted myself in my office earlier. Wow, David, 1,000 points. I would have gone this whole office hours talking away. So yeah, if anyone came by the video, I was just like, wow. That's what when you hit the mute button over there. Like, I can't hear you. And I was like, oh, let me look over that mute. I was talking about what I send out sometimes to other classes and trying to find certain things. Yeah, we have crazy mini terms sometimes. You have to play it by ear. We've had issues with MyPearson. If you have issues with MyPearson during mini term, then it literally you have to like because like if you lose a day or two on mini term, mini term is only like 12 days of class. And if you lose a day or two, you just lost. You lose 2 days, you just lost 1/6 of the semester. Like you lost 16.66% of the semester. Like that is gone, or 18.33%, I think. No, 16.66. So yeah, you can lose a lot of time in main term by accident or some sort of like tech error. So that's why we've had to like call audibles and be like, hey, because we lost 2 days this week and we only have 5 days of the week. The main term's so fast, and if anything goes wrong in main term, like literally every hour you're waiting for something to be fixed in mini term it's at a 15 times pace. So every 2 hours is like a day in mini term going by. So if you have to wait a day for something to be fixed, you just waited like 2 weeks for it to be fixed or something ridiculous. Because of the time speed up. You just can't have things go wrong, which I have had because sometimes things go wrong. Usually it goes well. Usually everything's fine. But then I've taught, if you go over here and look at my courses, if we go to all the courses I've taught, you can see how many times I've taught mini term. I was even talking to the university about I want to help out other instructors because I've taught mini term now. There's all my summer mini terms. So I've only taught 201 during mini term. So I've taught mini term as far back as 2018, taught all those mini terms, and there's another 2019 I also taught. I don't know why that's categorized differently. And I've taught winter mini term since it existed. So I have almost 7 years of teaching mini term, 7 years of it, and so I know pretty well the pitfalls that can occur. And I hope to maybe help other instructors with that because you have to know what you're doing in mini term. There are things that will help you be successful in mini term, and if you don't do them, you're almost doomed for failure because the students have to come in knowing exactly what you're doing. Like you have to if day one's a syllabus day, you just wasted like a tenth of the semester almost. If you're like today's syllabus day, we're not doing anything, you're like, well, no, you do this. You have them do the syllabus at home, and then you say like, well, today, and you'll have a test in 4 or 5 days. So here we go. Okay, chapter 6. Now about Brian's pedagogy on how to teach. This is a teaching stream on how to teach at the University of Tennessee. So here we are, Stat 201, chapter 6, MyPearson homework. Question 1. Okay. So on this first question, what are we being asked? They're asking us, what is the relationship between certain variables? You bet we're having class. I will record it though. So if you can't make it in, don't worry, be safe. Be safe out there, Rutong. Good to see you, Rutong. When you think about weight of an apple in grams and weight of an apple in ounces, do you think these two variables would explain each other? Like if you're like, let me weigh this apple and see how much it weighs in grams. And then you're like, let me see how much this apple weighs in ounces. Do you think you could maybe figure that out or predict it? You're welcome, Rutong. Do you think you could figure that out or predict it? Do you think you could? What do you think? Do you think those variables are related somehow? What would you say? Related, unrelated, just like random relationship? What do you think? The variables have a relation, they have no relation. Thoughts on that? Yeah, it's both it's just a conversion metric, right? Like you're just converting between pounds to whatever. You're just changing it around. So you could use either or. It doesn't really matter. Rock knows. It doesn't matter which one you use. So either could be used to predict the other, and we would do that right there. Now, what would we expect? It would have a like perfect linear relationship because they explain each other perfectly, and they go like if it weighs more pounds, it weighs more ounces. So perfect, linear, straight, going upward. And next we have how much ice cream we sell and how much air conditions we sell. What do you think happens when we use more air conditioning? Do you think we sell more ice cream? So if we use more air conditioning in the house, what do you think companies are doing? They're selling more or less ice cream. You have to think, well, like what time of year we use more air conditioning and what time of year we sell more or less ice cream. So what do you think is the relationship? When more air conditioning is used, when there's higher air conditioner sales, I'd say it's more. Because don't worry, throw you some points right here. I think there's a positive relationship that the more AC is being sold, there's more ice cream being sold, right? And if less AC, less ice cream sold because of the temperature outside. So with that in mind, it depends on if we're selling AC or we're selling ice cream. So it's like it kind of matters. It matters. So I don't know. You could do either one as your Y variable of interest or your X explaining the other. But it depends on what you're interested in. I'm interested in selling ice cream. Okay, then the Y variable is ice cream. Once again, this is going to be a positive relationship where you sell more ice cream, you sell more air conditioning, and it'd be mostly straight. So positive, linear, strong correlation. Unless less AC. Yeah, exactly. It could be, right, David? There's always ways to like outthink the questions. This one's really good though here. Think about this. You're a college freshman. You're like, what is my shoe size? Or you're like, what's my GPA going to be? The Y variable of interest is the one we wonder about. You say, why? Why? I need to go grab that thing of like the numbers and stuff going in the background. I could make that today. Dang it. Should have done that at the start. Should have taken the 5-10 minutes to put that here so we could hit a button and get like the confused number math thing going. I've been meaning to do that for a long time. And with this, what do you think is a better why to ask about here? Your shoe size or your GPA? Which one do you wonder more about? The why is what you want to understand. It's the why. So which one do you care more about, your shoe size or your GPA as a college freshman? Which one would you wonder why more about? Technically, if you're selling shoes, then it'd be shoes. But let's go with what most college freshmen might wonder about. Well, your shoe size is probably not going to get you expelled. GPA might, though. So and this is the tricky part because the Y variable of interest is the one we want to understand. And so GPA is the one we probably want to understand, and maybe shoe size explains it. Do you think shoe size and GPA are related? Like, you have large shoes, you have high GPA, low GPA. Do you think there's a relationship here? So we probably want to understand GPA using shoe size. Shoe size would be the explanatory variable, and we'd want to understand, which is the response, what we talk about GPA. So we'd want to understand GPA. I don't think there's a relationship, right? So it'd probably look very random. So it would have no direction, no form, weak correlation, look very random. This one here is probably one of my favorites. You're driving your car and you're like, how far have I driven? Or you're like, how much gas is in my tank? So while you're driving your car, we can actually get in the car. Wait. There we go. Okay, what do you think I'm thinking? Am I thinking how far have I driven or how much gas is in my tank? What do you think? I'm driving along right here, and I think, gosh, man, it's so beautiful here at UT. Man, it's so nice here. And I'm like, maybe I shouldn't be driving along this area here. You think I'm thinking how far have I driven? I don't know. I might be thinking, can I hit 88 miles per hour? But I think a lot of people often think, I got to raise my hand up here so I'm throwed up. Whoop, I can't even go to the ceiling. Can I go through the windshield? No. See? I'm in the car. I think people are probably thinking, how much gas is left in my tank? That's probably what they're thinking, I think. So if they're thinking how much gas is left in their tank, that would be the Y variable of interest because they're interested in, they want to talk about how much gas is in their tank. And think about this, what might explain how much gas is in their tank? What might explain how much gas is in their tank? What might explain how much gas is in your tank? What do you think would explain how much gas is in your tank? So the Y variable is the thing you want to understand. I want to understand how much. Well, true, that would be a 1-to-1, but also how far you've driven. How far you've driven would explain the remaining gas you have, because the gas is what we want to understand, how much gas we have left. We want to understand how much gas we have. And we're like, I've driven really far. I bet I have a lot of gas left or a little gas left. I've driven a lot of miles. I would assume I have a lot of gas left or a little gas left. And look at the way my hands are pointing when we figure out the answer to this. I've driven a lot of miles, and like very high amount of miles. I probably have a lot of gas left because I haven't filled up in a long time and I've driven a lot of miles. So I haven't filled up and I've driven a lot of miles. Do you think I have a lot of gas left or a little gas left? If I've driven a lot of miles, I probably have what? I haven't filled up. A little. Now, because my hands point in different directions, put a plus or minus, this indicates a what correlation? We'll throw you some points. Because my hands go in different directions, this indicates a what correlation? Because my hands go in different directions, it indicates a negative correlation. Great job right there. Yep. Negative correlation is when one variable, you can see right here, this is a negative correlation. One variable increases, the other variable decreases. This is a positive correlation. One variable increases, the other variable also increases. This is a somewhat flat, weird looking thing, not really well correlated, as is this one right here. So what do we see in this data? As one variable increases, the other variable what's? So as number of people working increases, the sales tend to what? I'll put the mark in here for the question. As number of people working increases, sales tend to increase. So guess what? We saw a graphic that shows that. It's like, and you see like there's a few people and there's like a gap in the number of salespeople. And you see that gap right there, 4, 5, 13, 13. You got a bunch of 13s. You got all those 13s right there that are all grouped up. And you got like 19, 20, 21, 22, which goes right in here. And then we should see across here another 22, which we do. Then you've got 2 observations at 18, and that goes 23, 24. Then you got the last point here at 26, or 20, 26. And that looks perfect. Yeah, good job. Check the dots as you go across. What would you say about this association right here? Boom. We already said it. It's a positive association. As one increases, the other tends to increase too. What would you say about the relationship? This goes to the form. The ways in which we describe correlation are strength, direction, form, unusual features. Make sure you can explain all 4. The strength of this is very strong, I'd say. It's very strong because, excuse me. It's very strong because the relationship is pretty tight around the linear form. Linear form, pretty tight, as in it doesn't have much spread around it. So that is a pretty strong positive relationship that is mostly linear without any outliers. So I'm going to say it's linear, and we might be good to go. What would you say about the strength? I said it's very strong. I already said that. I said that out loud. Does it have any outliers? No key outliers. We don't see something way down here as an outlier. There's no major outliers. Try to find big ones. No big outliers. Nothing weird going on. That's a good question. Okay, this next one's very similar right here. What do you notice about the relationship right here, David? Let me throw you some more points. Keep working away and asking questions. The relationship here, as capacity increases, price tends to do what? 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 Increase. Now, that narrows it down to graphics. Which 2? A, B, C, D. Which 2 have we narrowed it down to that show a positive relationship? Which 2 have we narrowed it down to? We want to look for a positive relationship. So we have to know what a positive relationship looks like, A and C. So with this, let's take a look at C first. With C right here, you'll notice the third to last hard drive has a higher price than the one before and after it, which would be this one right here. No. Higher. Watch how it goes. Higher, higher, higher. That's lower. Let's look over here. Higher, higher, higher. It's hard to see, but maybe that's lower. And then it keeps going up, 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 up. So there is one that breaks the trend back here on hard drive number 4. And that would have to be this hard drive right there, which it's very hard to tell. I have to zoom in really big, but yeah, you can barely see it. It's hard to tell. So it looks like this is the graphic right here that follows the trend in the data. We're good to go. It looks to be positive, mostly linear. I do hate this question because I have made a mistake or two on this one. Because when you look at this, there is a bit of a parabolic relationship or nonlinear. What I'm saying is you've got this sort of bend right there. It's got this point that is kind of a bit of an outlier. We're going to find out the hard way. What would you say? Well, it's positive. I can tell you that much. It goes up. That's easy. We're going to say I'm going curved. I'm doing it. I'm doing it. I did it. I said it. Yep. I mean, it looks, you can tell it's got this curve to it. It's a little hard to see, but it's more flattened out here. That's a tricky one. Is this strong or weak? David, go out on a limb here. Is this strong or weak? Remember, strength is tightness around the form, and I just drew the tightness. Is this strong or weak? This is super duper what? This is super. Oh, don't worry. And Catherine, good to see you there. David, 1,000 points. David, this is super duper duper strong. This is one of the strongest relationships you can see. This relationship is in like a 50-year marriage, and they're going on a honeymoon to Vegas, and then they're taking a worldwide trip, and they're going another 30 years marriage. Strong relationship. Good for them. So what you see when you see a weak relationship is the points are more scattered out like this. This will be weaker. I can draw like weaker and stronger. The form doesn't matter. Everyone knows. Even if you do a parabolic relationship, this parabolic relationship is starting out strong, and now it's getting weaker. And now it's getting super duper weak. Do you see how when I get weaker, it funnels out? So the strength would be how tight it is. And if you notice, it gets more funneled out, meaning weaker. Does that make sense right there? Well, so what you want to look at is how tight it is around this form. The form of a relationship is the pattern it follows. So this one is here, and you could draw a stronger linear form if you draw something like this, that if you draw a line, which is the form, the points would be tighter around it. This one has a weaker form. Both this graphic right here, graphic 1 and graphic 2 on the edges of the screen, are just examples of linear relationships. Graphic 3 is a nonlinear, is graphic 4 a nonlinear. The form doesn't matter. It's the tightness around the form that dictates strength. So this is very tight, so it's extremely strong. Relatively, very strong. So with this right here, there is one point that is a pretty big extreme outlier, and it looks like it'd be overpriced. If you think about how the line would go, this is a little tricky of a one, but I think you can see it. The rest of the data follows about that. If you kind of draw the linear pattern, you can see the line doesn't fit it perfectly, and so this is over the prediction. This would be what we predict, and this is over. Data analytics 4? Yeah, email it to me. Email it to me, yeah. Yeah, let me know. Email it to me. Yeah, Catherine, email it to me and I can take a look. Thank you, Catherine. Email it to me as soon as possible and say, hey, Brian, you said you could do this during office hours, and I'll make sure it takes some time. Remember, stat21 dash initials dash title here. Email as soon as possible, Sydney. And then I'll go home tonight and I'll reply to all emails, and then I'll get some sleep and I'll work out and I'll eat breakfast and I don't know. And I'll sleep again. Thank you, Sydney and Catherine. Send me them as soon as possible. I'll take some quick looks. I give some quick advice as quick as I can, because sometimes I get a lot. So I try to do the opportunities for everybody as much as I can. First come, first serve. So it would be overpriced and is the 32 terabyte, as we can see here. What? Underpriced? No. What did I do wrong? It fits the pattern. I guess if you fit the curve. Question. I think they're talking the curve pattern. Question's gotten me before. I know that. I knew it. Well, what form are we fitting to it? So you get to see the answers right here. There we go. No more wrong questions. Delete. Let's do another one. You ready, David? Let's knock out another question. Here we go at the 28. Yeah, thank you, David. Throw that positivity my way. I need it. I teach the class. I shouldn't be getting questions wrong, but everyone's human. The relationship between two variables can be studied with a scatterplot, yes or no? The answer exists on the screen right there. Dave was answering yes to the last one. Can every single relationship of variable type be studied with a scatter plot? This is only when what? Only when what? And why no? And why no? Like, no. I like it, David. Why no, David? Why no? Puppet Shark says yeah. Why no? The no is the important part. Why no? The answer is no. You have to have two quantitative variables. The scatter plot is only the visualization of two quantitative variables. So, yeah. Mubot, chill out, man. I'll throw you some points for that, David. Scatter plots are the visualization of two quantitative variables. Yeah, so nice, easy question right there. It's like no one should get that wrong. That is a multiple choice question that you get infinite attempts on. It's you can just reload it. You can do similar question. Which of the following best describes a response variable? Is the response variable the y or the x? So don't even read their answers. Thank you, Catherine. I'll take it out a little bit later here. I work until 6:55. Then I come home. Then I eat. Then I work out. Then I talk to my wife, or I talk to my wife while doing that. So I will look at it tonight, but it'll be a little bit later because I'll be doing office hours, then class, then home. So be a little bit later. The response variable is the x or the y. The response variable is the x or the y. What is the response? X or y? I'll go sleep in the snow. It's the y. Thank you, Catherine, so much. I had a quick story time, and then I'll answer this question. A year or two ago, probably no, like 4 years ago, because it was before I went to Texas. So I had a student. See, Catherine, I had a student who emailed me, and they said, when I joined an online class, I expected my instructor to be responsive. I emailed you this morning, and you have not emailed me back. And I wrote this email like, well, here's my schedule for the day, and I deleted it, and I was like, thank you for emailing me. I understand that you needed help, and I'm sorry it took me a while to get back. I was like, like I expected my instructor. I was like, wow, okay. I'm trying here. I'm trying. Okay. Response variable is the variable that you hope to predict or understand. True. The variable that might change in response to a change. Response variable is the dependent. I know, right, David? Response variable is the dependent. Yeah, because X is independent of Y. I don't like the way they phrase that second one. The first one's the better way to phrase it. So when you want to understand, I know that's wrong. I did that on purpose because I wanted that answer to be right. It's the best answer. That was the best answer. The Y variable is the variable that you're interested in, called the response variable, the predicted variable, the variable of interest. Yeah, that's what the Y variable is. Okay, we are getting almost done with the homework here. We got this. I believe you over MyPearson. Just Thanos MyPearson away. Thank you, David. That's early. I'm gonna make that a quote of the day here after this question. I like that. Right here. Okay, question 6. Let's do it. If we assume the conditions for correlation are met, which of the following is true? Briefly explain. A correlation of negative. What does negative indicate? It indicates the what of the correlation. I'm thinking of a D word. The negative indicates a what of the correlation. Negative indicates the what? Just direction. Strength, direction, form, unusual features are the 4 ways to describe correlation. And the stronger it is, kind of the slope. It is the slope. Good answer, Sydney, right there. There's some points. It's kind of the slope. The direction is the slope. Correct. And with this, like literally, you can call it slope, but we'll call it direction a lot of times. And then we'll call it slope in chapter 7. Mubot knows about that. So it is very strong because it's close to -1. So this should be true unless I'm reading it wrong, but it should be true. Number 2, multiplying every value of x by 2 will double the correlation. Correlation can only go from -1 to 1. If you were to double a correlation, you would get something outside that bound, so that is false. The answer is correlation is based on z-scores, and multiplying by 2 would just scale the data to be bigger, and it would not change the z-scores by which the data was calculated on, so you would not change the correlation at all. Correlation is not changed by shifting and scaling. Correlation is not changed by shifting and scaling because it is not changed by z-scores. A little bit of a mini lecture there. The units of correlation are the same as the units of y. I actually just said the answer to this one a second ago. Is it A, B, C, or D? Who knows? Take a guess. Don't worry about being wrong. Because I said correlation is based on something. And if you know what that is, then you know the answer to this. What is the answer here? You got to remember what I said correlation is based on. You can see what correlation is based on. Take a guess if you want. Don't worry. Multiple choice. We get it right. I said correlation is based on something. I'm going to go find the equation to show you. It's not true. Take another guess here. Let me throw you some points, David. It's not true. Good guess. It is z-scores. Z-scores are what? Unitless. Z-scores are unitless. So since the z-scores are unitless, then correlation would be what? Since correlation is based on z-scores, and you can see it right here, I like this equation. Since correlation is based on z-scores, see how it's the observation x minus the mean of x over standard deviation of x? That's the z-score for x. So what would be the answer? If z-scores are unitless, then the answer is what? Take a guess. No more points in the chat if you just guess. Don't worry about it. I'll say the answer after this one. We'll be down to 2. Z-scores are unitless. And correlation is created from z-scores. It is D. Don't worry. Hey, I'll throw you some more points about it right there. It is D. Great answers, everybody. Don't worry. Its correlation is unitless because z-scores are unitless. There we go. That's correlation is unitless. It's just like z-scores. Z-scores don't have a unit. They're not units of the problem. Me about tossing out some points. Don't worry about it. We just practice. That's all we do here. We go back. What is correlation? It measures strength, direction, form, and unusual features of linear relationships. Does it measure the strength of all relationships? No. It only measures the strength of linear relationships. It is a measurement that is not appropriate for linear. No, it is used on linear. It tells us which values are outliers. Not really. It measures the strength, direction of linear relationships, and also tells us, well, the form is linear. So that's got it. Last one. We'll get the homework done right here. So good work. We should have hundreds on the homework. I've marked every question in the video. So you can come back, or people can come back and do all the questions. Which of the following is true for correlation A, B, or C? A, B, or C. And Mubot already got a little bit mad in here. Said, if you remember what Mubot got mad at, you'll remember not to mark this. Which of the following is true? This is kind of a good review question, David, because it was like one of the earlier questions had us doing this too. Which one do you think? Take a guess. It is B. Because remember earlier we had 2 variables that were not quantitative and we couldn't do it. We need a straight association for a linear relationship. We don't want there to be outliers. Yeah. 100 on the homework. What do you want? Well, it's people's choice. Name something to do. We just did the full homework. It took 24 minutes and we went kind of slowly, asked a lot of questions, but at this point you should have the homework completely done, full homework done, and what are you going to do next? It's your call. Head over here. I am so tired today. I am so tired. Oh my gosh. Might even try to review some assignments here. That's good. Chapter 6 quiz. Yeah, which one do you want to do? Chapter 6 quiz. Great job. Time to random people. Okay. Tell me a question to do. Chapter 6 quiz. Which one, Haley? Good to see you there, Haley. Name a problem on Chapter 6 quiz. We'll do a few of them. I'm like so tired. I think it's because I had a really good lunch. I went to the... You ever go to the... what is it? It's got like the tikka masala, the place in the student union. So good. I'm addicted, I think. I think I got a problem. The only cure is more tikka masala. Just gonna say I need more. They got me addicted. I'll say I need more. It's too good. Need 2 servings. 2 servings. Chapter 6. Yeah. There we go. Hamilton depression rating. What? That's all right. Would you like to hear? I don't want to do that. Okay. Oh my gosh. David, this is how many questions there are. Look at this. Look at how many there are. This is how many different questions there are. It's like the longest question anyone ever wrote ever. We don't have time for that. Oh my gosh. We can do it. Some of these are way easier than they look. I love those. We didn't do those lately. We haven't done them. They're so much fun. I like guessing ones where people are like, how would you know that? And you're like, oh, I just gotta see the pattern. Have you seen it yet? Which one? Hamilton. Did you see it, David? I didn't see it. 22? Oh my gosh, thank you. How did I skip it? Is it this one? Oh, you want 22 though, right? Okay. Most roller coasters. 23. Okay, 23. Oh, here we go. Okay, yeah. Give me the start of it, like a study compared, because I'll always read the first few words. Thank you so much, David. Points you right there. There we go. It is here. It does exist. A study compared effectiveness. Let's grab that. And here we go. I'm marking it up. And let's go right here in the 41:33 mark. And the quiz. Okay. A study compared the effectiveness of antidepressants by experimenting on people. They gave them a placebo, and then they looked at the drug improvement on the depression scale right here. You can see right here the mean improvement levels for antidepressants and placebos for several experiments. And here we go right here. So they're correlating these values to see if placebo improvement is related to drug improvement. And for the most part, this is a mostly linear relationship. There's a bit of weirdness towards the middle where it kind of dips. But whenever you get something like this, you want to go in and draw a line and see if it mostly follows a line. You can see how strong it is, mostly strong. There's a bit of non-linearity in here where it does a little bend. Not bad, but I would say this is a moderately strong to strong correlation, probably in the neighborhood of closer to 1. So it's probably going to be about 0.92 or something. Maybe it's pretty high. Strong positive correlation. No big outliers or anything weird with it. Is it appropriate to do correlation? It is, because it doesn't matter that it's positive. It's linear and does not have outliers. The correlation is this. Oh, man, I said 0.92. Been cooler if I was right. Explain what the researchers have learned about the results of this experiment. They would have an association and a correlation. They can't say one causes the other, though. The effect of antidepressants given in an experiment does not appear. No, it is related. Experiments that showed a greater mean improvement among patients who took an antidepressant also showed a greater mean improvement among the placebo. That sounds right. Since it's not appropriate, no, we didn't do that. And I think we got it. It's basically they both increase. Yeah. Does that make sense, David, right there? Because what we generally see, I would say the higher placebo improvement is associated with or correlated with a higher drug improvement. Yeah. Because we see, and we can't say it's like we know it will happen. It's just to say that there is a correlation that we observe. We observe a positive correlation. Mm-hmm. Good question. A little tricky, but tricky that it's a multiple choice there. So there's not any issues. Never read their answers first. Always think about your own answers and do the QQ straight enough. No outliers. It's two quantitative variables. It's straight enough. Doesn't have any big outliers. So that's how we check to see if we should be doing correlation. Let's do a few more, right, David? We'll do one of my favorite ones while you find one you want. That one's not tough. It looks tough, but it's a bunch of blanks. We'll do this one right here. Here are several scatter plots. And I love these. Graphic A has what correlation, David? Do you know? I'll answer some of these. You want to take a shot at it? Which one of those correlations up here do you think is graphic A? I'll show you how to do these. What correlation up there is graphic A? Okay. Well, graphic A goes down, so it must be what? Graphic A goes down, so it must be what? That can help us out by knowing graphic A goes down. So it has to be what, at least? And that narrows it down. Good guess, David. I'll throw you 1,000 points. But it does go down. So what you want to do generally is draw the linear relationships in these. Now that 0.006 is actually where, David? If we go here, that 0.006 is actually where? And you are correct. This is the negative 0.487. This one is the extremely negative 0.977. This one is the nonlinear relationship, that is 0.006. And then this one right here is the positive one that's very strong at 0.77. Drawing the lines can help a lot. This one is moderate. And does that make sense, David? Right? Yep, it's graphic C. You got it. And so we can do here the negative. And then B is positive 0.777. And then this is the 0.006. And then this is the negative 0. There we go. That's got it. There should be another. Here are some scatter plots. Hey, here's another one. And so now what I would do first is draw a line. Let me ask you this. Which of these graphics is the strongest positive? A, B, C, or D? Which of these graphics is the strongest positive? A, B, C, or D? So you have to ask which is closest around the line, A, B, C, or D? Which is strongest positive? Probably between two. Just take a guess. It is D. You got it. So D is the strongest positive. This is a non-existent. This is the strongest negative, and this is the second strongest positive. So we can eliminate this way right here. Strongest positive is D. Second strongest positive is here. And most negative is here. And then the one that's closest to 0 is right there. It doesn't matter if it's positive or negative.
It doesn't matter.
It's closest to 0. There we go. Yeah. I don't know. I really love those questions. Like the here are several scatter plots. I guess there's only a few of them. This one gets people a lot too. We'll do these. But these people, these scatter plots. So I say these scatter plots are like, these people right here, what are they doing? Going to fall asleep. What they're going to do. Okay, getting the timestamp. Okay. So which of these scatter plots are the following? So what you want to do before answering any of these is actually draw on the scatter plots. It'll help out a lot because the first thing it's asking is, which of these have a negative association? Well, that's an easy one. To figure out a negative association, all we're going to do is just go to our scatter plots right here and see if they follow a negative line. 1 and 4, I like that. I think you got it because we go 1 and 4. There we go. Which of these are linearly associated? So this is answer 1 right here. Do you know which ones are linearly associated, David? Which of these are linearly associated? Which of these would have a line go through them really well? And the line would well describe the data. You are right. It's 1, 2, and 4. That's best I can draw. Which of these are weak or moderately strong? So weak or moderately strong is not very strong. And weak could mean basically no relationship. So we'll go here for 3. and this is weak, and that's moderate. That's where 3 is at. Which of these are very strong? Very strong is a very tight relationship, which we'll do as 4, and that's very strong, and that's very strong. So here we go. Which of these has a negative association? 1 and 4. Wait, what? Oh, show no association. It's graphic 3. Sorry, whoops, I did click it right. Graphic 3 shows no association. Which of these show a negative? 1 and 4. Which of these show a linear association? Great job, David. Linear is 1, 2, 4. Which of these scatter plots is moderately strong or moderately, whatever, 2 and 4? I think they changed the question a little bit. Which of these scatter plots show a very strong 1 and 4? Ah, what'd I do? Weak or moderately strong? Weak. Oh, no, because that's the one we got wrong. Because they're not counting weak as non-existent. So what's the answer to this one? They're not counting weak as non-existent. What's the answer to this question D? They're not counting weak as non-existent. They're not counting non-existent and weak as the same thing. They already said there's a non-existent, no association one. It is just graphic what? It's graphic 2. So they're calling this one the no association. Man, I haven't gotten that one wrong in a long time. It's because they count that one as the no association, and then they're doing weak. So this is classified differently. They're classifying this one down here as no association, and then this is, they should have just said like, we're going to classify 3 different ways as non-existent, moderate, and strong. And this is non-existent, which could also be called weak. Weak and non-existent, but the weak tricked me. It tricked me. Can we do brain size 1? Yeah, let's do that. We might have to end right there because I'm missing questions. How's the brain size 1 start? Is it the fMRI or whatever? Oh, is the next question? Oh my gosh. You're right, David. All right, here we go. Good catch, David. Thank you, David, for being here. Got a lot of questions done. I think everyone who uses these videos gets help, ask questions, start early. You know, that's my thing. Start early on the assignments. So 5123, drop it in. Here we go. A study examined the brain size measured in pixels, counted on a digital magnet resource image, resonance image MRI of a cross-section of the brain, and IQ, 4 performance scales on the Wechsler IQ test for college students. Scatter plot to the right shows the IQ performance and brain size, describe the relationship. Now we got a bit of a problem. Hey, what's up, RotoWave? Hit the RotoWave points. 5,000 points for David right there. There's the RotoWave points. That's the highest button we got. Give shouts to RotoWave in the chat right there. Good to see you, RotoWave. Do we have a RotoWave level? We should have a RotoWave level. So there are some problems with this. If you notice, it kind of goes like... Good to see you. Have I seen you on Campus RotoWave? I think I have, right? I know. No, of course I have. I know who you are. I know exactly who you are, RotoWave. You took 320 also. But you didn't take 474. It's all right. It's all right. Like, I mean, I haven't seen you much since 320. I've seen you a few times at some like the festivals and stuff, like outside when we do events. So good seeing you. I hope to see you on campus more if you're still around. So I'm like so sleepy today. I don't know why. And I got like 6.5 hours last night. That's probably why. What do you notice right there, David, about that relationship? What do you notice about that relationship, David? RotoWave just came in and said, like, give a lot of points. I love it. It's what we build over time. I love when we have people like swing by. Well, it's got a little bit of what, David? It's got a little bit of I'm looking for a certain word right here because I think they're going with that in the question. It's got a little bit of what? Because it goes non-linear. So it's got a little bit of non-linearity. We'll see if they go with that answer. I'm not going to click it. I won't get it wrong. It's very weak, possible, or no. They don't even talk about the non-linearity. Dory, I'm now bothered. Well, Adam Spanbauer is awesome. And shouts to Spanbauer. He created an Inescapable game. He created the Dante's Inferno game. He created a WarioWare game. So shout outs to Spanbauer, who's an absolute just beast at what he does. And so RotoWave and David, I'm gonna get some energy. You know what it is? I drank a Monster yesterday, and now I'm addicted to Monster again. Yes, he is. He created that like on a weekend or something. And he created it before ChatGPT, I think. So Adam Spanbauer created these applets right here that we use. He hosts them on his GitHub. So I'll show us. You should be able to see his GitHub right here if I go over here. Right there, he is. There's Adam Spanbauer, really great guy, really awesome colleague, data science instructor, mostly Python and R. For paying, mostly write P5 JS for fun. Check me out, the span setting on Instagram. So there is Adam Spanbauer. Really good. Yeah, he's everywhere. He knows his stuff, and he's just really fun, great guy. Coding and everything. My thoughts, articles were in Wedding Ring Classifier. Congrats to him also. Just a lot of big life events, a lot of cool stuff, and just I'm lucky to work with some really awesome people, and pretty much thanks to our department head who hires and keeps around really great people and creates a culture of that. So wherever you go, wherever you work, bring a good culture with you that we teach here at the University of Tennessee of treating everyone with respect. And we're all Vols. Vols help Vols. Vol means all. Till then, bye for now, everyone. Bye. Great job, David. Great job, everyone.